Well, hi, good morning. Thank you so much for joining me in my shop, and thank you very much for the super thanks. It's June 22nd, and just before I start working on the radio, I just had an experience I'm going to share with you for just a couple minutes, something you just can't believe is true. Now, take a look at this record here. So, Atomic Rooster is a band. I believe this band is fairly well known in Britain. I don't think it's in it, but here in North America, this band's almost unheard of. This particular record here is a little bit beat up, isn't it? This was brought back from Britain by my sister when she went on a trip in her late teenage years to England. She brought this back for me, and this quickly became one of my most favorite records. I love this record. And now I've got an American pressing and I've got a British pressing. This is the British pressing of it. This just blew me away. It's the only record I have where one side of the record, yes, it's all scratched up. Yes. Sorry. I feel terrible. Look at what happened to this record. It's like one of the few records I've ever had scratched up like this. So an accident happened with it. But anyway, look at that. This beautiful image here. Nothing much about the music. It's all written on the other side here. It's the only record I've got that's got. It just gave up one side of the label. I just thought this record was so special. The recording was much better than North American records. Quite clearly when you listen to this. Fantastic. I love this record. And I've listened to it a million times. What did I just find out? I found out, to my shock, this band is still touring. And some of the guys in it are the original guys. They are still out there playing music. How did I find out? Thank you, YouTube. I just kind of stumbled across one. I think I was looking for just some Atomic Rooster music, and oh my gosh, here they are playing in a bar somewhere. It's last September they were playing in a bar, and this is the guy who plays the keyboards. That's the guy in the keyboards, and you see his hair. It still looks like that, but it's white. I'm not sure about the rest of the players. I know the original drummer died as a young man in the mid 1990s. So anyway, fantastic band. I wasn't too impressed with the videos I saw, but nevertheless, the fact they're still out there doing it, and I had no idea. I thought that band disappeared in the 70s. Just went on its way. Okay, so that makes me kind of happy in a way. Now, what about this radio? Can this radio make me happy today? I think there's a good chance that's what's going to happen here. And I have to warn myself, yeah, Jim, you could be very embarrassed. Because this could be a case of me chasing smoke and mirrors, making a bad observation early on, and then chasing a problem that really doesn't exist. Or a problem which has nothing to do with the area that I'm fooling around in. So, the last thing I did is, the last few things I did yesterday, this is the oscillator transformers. These are the oscillator transformers. There's 3 coils over here. This one appears to be the broadcast antenna coil. I don't know what to say about this one yet. Probably another oscillator coil. I don't know how that could be. But anyway, I, through a lot of effort, was able to prove conclusively the primary of this transformer is operating, and now it's time to find out from the secondary onwards. The basic misbehavior of the radio is you can send a signal into the antenna terminal and it never makes it to the first tube grid. It's gone somewhere in here. It disappears and never makes it. So it would appear to me it can make it all the way through the switch, the primary, but what about the secondary? And that's what I'm going to work on today. It's another beautiful day here. There's just one day after another. It's fantastic here. So I don't want to be too long at this. So I'll probably just do a little bit and then go outside and play. Coffee first though. Okay, while I was drinking my coffee, I was watching the end of the Atomic Rooster video. I was watching it's them playing in a club just last September, and at the last thing, the guy stepped up to the microphone and goes, "Thank you very much for coming and hearing us after all these years." So my guess is they were gone, and somehow they've reformed themselves and have gone out to do a few gigs, one of which made it on YouTube. And there's a few others out there too. Okay, enough of that. What about this coil? let's start with doing the basics here. I'm going to measure the resistance of it, but I should really make sure of where these wires are going. And this one's heading over to one of the IF cans. Okay. This one is going up into the switch. Let's see if we can figure out what it's doing here. It was very helpful to me yesterday figuring out just which wires were connecting with which when. So right now I'll put it in the AM mode, which is the middle setting of the switch. And this is the wrong wire. It's this one here. Coming down to this terminal. You probably can't see what I'm doing. It's connected to this wire which is heading up to the capacitor. So in this setting we're hooked up to the capacitor. In this setting we're hooked up to this coil. Oh boy, I don't know what to think. And in this setting, this is what I'm looking for now. The wire is open circuited. So if I keep it set like this wire is going nowhere. Assumably the coil is no longer going to be affected by connections in the radio. I can make a real measurement here. The bench is getting a little crowded. I want to thank you for watching these videos. A number of you are sending me some emails now with different ideas and observations you've made, and I appreciate the fact that you're carrying on with me day after day as I proceed very slowly through this. I'm certainly well aware that there's a fast approach here, but I don't want to take it because I think it's too risky, and that is just to take all this stuff out and really look at it. But so look at that. So here I've got pretty firm proof that the secondary coil is continuous and the primary coil is continuous, and there isn't any problem there. Maybe sometimes when you're repairing a radio like this, when you chase a problem long enough, you can just chase it right out of the radio and it's gone. I think we need to operate this radio before I do too much more. And something else I need to experiment with a little bit is the battery situation. The battery that was in here, I removed it. Then for some time I had a clip just connecting the battery points here, forsaking some of the bias doing that. But I don't have the clip in at all. So I don't have a battery or a clip. And I think I've operated the radio once or twice like that. I may have made false observations. I may have to actually put a battery in here briefly just to prove to myself that can't be the case that I have all kinds of options here. Let's put it up here. So that's going on the chassis. Oh, let's put this quickly. Tough to get the jaws open. That's better. The other side would go right here. If we want to. I'm going to put it on, take it off, see if it makes any difference in the operation of the radio. And prepare for total embarrassment. And what's that mean exactly? It means I'm going to run for the hills if the radio starts working properly. Oh, I'm going to have to deal with the antenna. Let's steady it up here. My external antenna is not switched on down here. So I guess you could call this a moment to check in with reality. What is the truth here? So I haven't had this on for a little bit. I better just check it over and make sure the speakers are still connected. I didn't pull any tubes out. grid connections are on. This thing's floating around here. It's fine if we don't do anything dumb. So the objective here is make and break like that, see what happens. Band switch starting right in broadcast, and we will hook up the outdoor antenna for whatever it's worth. It's not worth very much. I don't think it's very effective. I'll give the radio something to chew on. You know, maybe I'll just keep it at the ready here. Just okay, stop and make sure the antenna is switched on, because I know it is not. And then we'll give the radio a try. Okay, let's power it up. Here we go. Dim bulb came on a little bit. And the volume is prepare for embarrassment. Dirt in the volume control. Okay, band switch. Not a lot happening there, but a lot of these radios are silent when there's no antenna on them. Can be silent. Sounds like I'm a better antenna. Okay. More volume. What have I been doing all this time? That's what I've been doing. Okay, radio still behaves the same way it was behaving before. Breaking into oscillation up around here somewhere. And then falling out of oscillation back here again. Don't be looking for the wrong thing, maybe. That's what I've been doing here. No harm, no foul, by the way. You spend a long time tracking down a problem that doesn't exist. You're bound to have understood a lot more about the item you're working on, and you're in that much better position to face more problems going forward, because I suspect there are. I mean, there's this. I don't even know how to approach that kind of problem. Now, so we can make it to 680, and we can make it to 640 on the dial here. Let me hook up my loop antenna here, which should provide a much better signal than the one I've got connected. Loop antenna is right behind me. Pretty quiet, isn't it? Pretty quiet indeed. Now, didn't this work last time? Turn this right up. It is turned right up. I got the right antenna wire connected. I'm not confused. No, it's the right wire. Hey, I still don't. Hey, I still don't have that clip loop connected. There's nothing happening here at all. Nothing happening. It's kind of strange. Expect something to happen. Okay, let's try this wire. So this is where the battery was. By not having the battery in there, from what I could see in the schematic, the ABC voltage cannot make it all the way to the front of the radio. So this radio has an ABC voltage. I don't know how to draw it. Okay, there it is. ABC voltage. Stronger the signal, the higher the voltage, the quieter the radio. So automatic volume control. It's actually going negative, so you might think of it as going down, but it doesn't really matter. The battery is just in series with the ABC voltage, so the battery just lifts it up. Or you can look at it this way, prevents it from coming down too low, becoming too a negative. It's a whole lot of nothing there. I mean, it's not even making a sound. Really? Shouldn't that be going doing stuff like that? But it's not. So the radio is definitely sensitive if you can get the signal into the right spot, but so that finger test kind of suggests to me that the output of this coil or transformer is making it to the first grid. Everything keeps checking out okay, but obviously it's not. The only position where it sounds like a radio is this one. Okay, since I don't really know what to do next, I'm going to do something. Stick a signal into the antenna from the signal generator. Kind of repeating over previous territory, but I think it has to be done. Right around the IF frequency at a very low level, fed into the antenna. And you can hear it. So and that tells me the IF is sensitive, and if we can get something there, it's going to come out the speaker. We're tuned around 640 or so with a low setting. No, it doesn't want to pick it up. That's 100 times stronger. Well, it's there. You know, this isn't so bad right now. The signal level coming out of my signal generator, we're going to check the calibration on it first. Yeah, it's right on. The signal level is moderate. Not unlike what you would get from an antenna. So I can feel the embarrassment coming up. Okay. Yes, there's a risk to working on these radios, and there's a risk to watching somebody work on these radios. You share the risk, I'm afraid. Mind you, I do have the volume up full here. What am I trying to do? And I gotta reassess this whole thing. At an absolute minimum, make the radio work on the broadcast band so it can pick up some stations, and that's really that's sort of the, if I can make that happen, okay, I've hit the okay button. Beyond that, getting everything working is good too, of course. But yeah, do I sound like I'm totally lost? I am. I'm totally lost now. So what if I put a battery in here? Is that really gonna give a boost? Which way was that battery in? Help me. Anybody remember? Um, is the tube running in cutoff right now, and that's why. So this battery's probably half dead. I'm not sure which half is dead, so I'm going to check it here. How dead is this battery? Ooh, 1.4. It's not half dead. If we put it in backwards, this way or that, I don't think it's not going to hurt anything. It's just going in for a moment. I want it to drive down the... Wait a minute, did I just say the signal is passing through this battery? Yet one end of the battery is connected right to the chassis. We must examine the schematic for sure, because yeah, let's spend a little bit of time on the schematic here. So once again, just making sure the radio I have has this number written on the dial plate. And I'm going to turn it down so we don't have to listen to the hiss coming out of it. So this radio is a little bit unusual. Look at this, it's got a triode, and a triode. That's just a little unusual. So I think what we're looking at here is the detector, a triode being used as a diode here for some reason. And then here the triode's being used as the initial audio amplifier, the preamp you might want to call it. And then we have another audio amplifier sitting here, boosting the signal more. And then we finally have the output tube sitting here, driving the speaker way down here. Notice they put a ground on this part here. Okay, not to worry about it. Just something to observe. Now, if we look at the volume control here, so we know all the audio is across this, the resistance element in the volume control, and it's coming from here, the output of the IF being rectified by this tube, or detected is the word. Once you rectify it, you can detect it with your ears. That's really where the word detect comes from. Now we go back this way, things get a little interesting. Earlier on when I glanced at this, I thought this was another variable resistor or potentiometer, but it's not that. This capacitor just shows a ground sitting close to here. It's just the way they drew it. So it's just a straight resistor, typically a large resistor, because the current flow on this side is nil, and you want to isolate the grids here. That's where this is going from all the business back here. Put a big resistor there, and then there's the battery, and it's pushing it more negative. Where's this ground that the battery was hooked up to? There's no ground here. You can't put a ground on this. So I think maybe I got to trace the circuit in the radio and see what goes on. I can start here. This is an easy spot to find on the volume control, and just follow the wires and try to find the 2 meg resistor here, and then follow along and see what's going on in this area. There's always a chance that this schematic is really not the right schematic. A small chance at this point, I think. Certainly not right in the case of this particular radio because of the changes that have been made to it. So that's what we'll do. We'll go to the volume control, find this terminal, it's the ungrounded one, and then chase it back to find the big resistor, and then beyond that, things should get interesting. Okay, let's go see what's happening here. Oh, this radio's on. Jim. Radio's on. Should turn the volume down. I forgot about it. Yikes. There we go. Okay, volume control is here. I'm going to pull the plug out here just to have a visual point of isolation. Power plug. So let's see. This is the grounded terminal. This is the ungrounded terminal. I'm going to put the, I'm going to put the schematic up on the screen with us while we do this here. Okay, let's try this out. There's the volume control that I'm looking at right now, right up in this area. Okay. So in the radio, at this terminal on the volume control, there's a wire going somewhere, and there's a resistor right here. These values can be read on this kind by body and dot. So body is red, end is black, and dot is red also. So that would be 2000. This would be a 2000 ohm resistor. Now, is there any such thing as a 2 million ohm resistor? Is that what that really is? 2 million ohms? Am I just figuring it out wrong? Eh? Is it 2,000 or is it 2 million, or can you even see? No, you cannot. There we go. Come on, get a grip on it. 3.1 megohms. That's what it is. How do you get 3.1 out of that? Put an ohm meter on it and read it. It's that or less. It's still in the circuit, so it's either that or less. Not 2, but 3. I don't know if that would really hurt a radio if where the 2 million is, you put a 3 million. It probably wouldn't make much difference at all. Change the rate at which the AVC reacts is what it would do, I think. Not much else. So let's assume it's good enough, or it's correct, or it's not a problem. So on the other, we also have a wire there. So here's the wire, and it should be going up into one of the IFs. So we follow this up, and it's disappearing. Oh, it goes way. It's this wire here. Can anybody see what I'm doing? It's this wire. That wire there. It's going right into the IF, so that matches. Okay. Now we'll continue along past the resistor. Let this light get on. So we'll follow this wire. Oh, wait a minute. I followed the wrong wire. I made a mistake. Did I? Yeah, these two wires I made a mistake. Coming back to here. A wire from here goes to, or just goes to the other IF. Okay, same sort of thing. So even though I followed the wrong wire, I got the right answer. Isn't that something? So now we'll follow this other wire, and it goes to this terminal down here that has other wires connected. Because they just want to make it tough on me. But for sure, that's that wire. So we're down to this point. A terminal on an IF. So does this on the schematic reach a terminal on an IF? So we follow the opposite side of the big resistor. Here it is here. We're supposed to run into the battery. We're supposed to run into the battery, which would be the battery here. The battery was going from ground to here. Silence is all I have to say about this. So the input to the volume control, looking at the input to the volume control should be coming on this wire here. And that wire is probably, has got to be this one. I notice at the same terminal over here there's a capacitor. And then that goes to a tube. Does that match? So we follow the wire over to here, and we find a capacitor going to a tube. But you know what? That's going to ground, in fact. It's going to a grounded terminal on a tube. So there we are, capacitor going to ground. So that matches. That matches. So we should have the audio from the radio traveling on this wire to the top of the volume control. At the same time, there's some DC that has developed on this wire, which is not of interest to the volume control, but is certainly of interest to the radio for controlling its sensitivity or volume. So in order to achieve that, they take a tap off through a big resistor because there won't be any current flowing. And then this should be leading to tube grids, one way or another. It may be a circuitous route. So we come down here again, meets up with this red wire and this gray wire. Gray wire is coming over to here. Oh, look where we've ended up here. How did we get to here? So this terminal is tied directly to here. This terminal is tied directly to this resistor. Okay, back on the schematic then. So we'll just go right through the battery like it's not there. So this terminal is tied directly to this coil. Secondary side, and it is the secondary side. It is the secondary side. Okay, so now if we follow the schematic a little bit further, we jump to the other side. The wire should be heading back to the switch on the other side. So on the other side, but the wire's not heading, oh no, this side. Heading to the switch. You know what's odd about this? So we have this coming across. Well, it's no longer odd. There's a wire going down this way. Okay, not odd. I was going to say this wire only connects to this transformer. But no, it actually splits off, connects to this one through another big resistor on the other side of the switch. So you're picking this coil or this coil, transformer rather, when you flip the switch. And you're picking both sides. Aren't you picking both sides? Okay, there's more down here. There's more over here. The both sides thing is happening in the oscillator here. What's going on with this now? How is this supposed to work? There was a battery in this radio soldered in. So where did he solder the battery in? It's from ground to this point. What's this point? So this point is a resistor. Well, it's got a capacitor to ground. And I replaced it. And then it has this resistor. So this is body and dot, brown, black, yellow, 100,000. Coming to this coil. And at this point, my brain is beginning to melt down. I haven't really sorted out what's going on. Yeah, I haven't really sorted it out. Yeah. Could there be, by chance, only one of these resistors in this radio? No, I already see another one up here, so we can't. And I don't think I have a parts list anyway. Sometimes if there's a unique component, you can find it on the schematic, and then you know where you are. It's good that you put this on. Make sure the wire's covered. So I don't know where this is. Where, like, this is just, I'd have to find this terminal on the diagram. Oh my gosh, am I ready for this? There's 4 terminals on this. I only see 1 coil. Where's the other coil? Well, there we are. It's missing a coil. Well, that's an interesting question right there. This guy's got 3. This guy's got 2. This guy's got 1. Only 1? Okay, can we see this on the schematic somehow? Let me blow up the schematic a bit. So we have the 3 coil one on the left coil. And we know which one this is, so it's got to be this one. This has to be the short wave. It probably says right on it here. Yeah, short wave right there. Okay, short wave. It's the short wave coil. Now, it's got a primary and a secondary. But I only see... Where did they hide the other coil? Oh my gosh, this is just the weirdest stuff. Well, would it be inside? They're not poking there. I'm trying to feel it, but that's probably not a good idea. How would they wind it on the inside anyway? They have to wind it on a tube and drop it in. Now, that should be easy to spot if it's in there. Let's see what we can do here. What can we do? Okay, we'll take a look with this camera. Again, the radio's off and unplugged. Could be a little charge in these capacitors though. It might not hurt me, but it might do something to my camera here. Oh, looks like we're going to get it in place to look right into this tube. Ah, come on. Okay. Oh, you've been looking at it the whole time I've been doing that. We need to adjust the focus here. Just bear with me a moment. Okay. Need a little more light. Do that, bounce the light up from below. So I see an internal wire at the top. I have to think hard about how this camera is aimed. Not really. I can see some wires in there to get it figured out. So this is, I can also point at things. So this wire down there is coming. Oh, it's heading down. I think it's coming out and heading. That's a pretty thin wire. The wire on the outside is not so thin. So I'm looking at the outside of this tube to see if I can see that it's 2 tubes. One slid over the other, like that other one. I don't see it. Okay, go back to this. So we've seen 1 wire. Now I got this thing in the way here. This wire. I can just move it out of the way a little bit. Okay, let's put it back. Let's push this back. So we can get down here. Well, I'm looking at my TV screen. I got up on my toes to look down in the tube, but I'm looking at a TV screen right now. There's no looking down. Any evidence of a second coil there? These terminals on the top, where are they going? Who's hooked up to what? Who's hooked up to what wire? I'm going to come around here. Just a sec here. Let me get this. So there's a heavy wire there. So this terminal on the top is hooked up to the heavy wire. The only wire I can see so far. What's the other terminal hooked up to? Now this is not likely to be hooked up to the heavy wire. It'll be at the other end. So this one here is likely to have a light wire hooked up to it. There's the wire. Let me get a better light on it here. And so we can't see right down inside right now. Let me just do this. Can you see further down? Good, I'm pretty sure down here. Light it down here. So that's stopping. Well, let's think about it. That's two wires on the inside now I can see, and they don't look heavy, and they look the same. And we've seen the one connection on the outside, and I bet you the other one is right here. There, you can see it. So, okay. So if I got this right, now I'm going to get a clip lead because I'm going to forget this, and I want to mark it. So I'm going to mark the outside coil. Really, it's actually visible. I don't have to actually do this, but I'm going to, for some dumb reason. Okay, there we go. So I'm stuck on a clip lead here. Those two terminals are the heavy coil, and the other two terminals are the light coil, which is hidden from view. And well, what are you looking at there? Hidden from view. It doesn't even look like it exists when you look at this. So this one, you can see this cardboard extra sleeve, sort of. Don't take that off. It's 943. Well, every day I get a couple inches further on this radio, but not much more than that. Oh, what's happening here? Everything's going off. That's an indication I should stop for today. I did not plan to do a long video. Here, I got a little carried away yesterday. So what have we found out? So we found out this battery is bizarre. We found out a lot of the wiring up here is likely a schematic. We found out there's a transformer here, a triple transformer here, and a transformer here. That's not a surprise, but now I have it visually verified. I'm going to take this off because I'm not going to forget this. I can see the heavy wires coming to these two terminals. So we have these two, and then one at the back. The one at the back must be connected to a wire. Must be connected to. Did I say something about it was going to stop? The one at the back. You would think it's hooked up to the capacitor. I mean, that would be the solid. It must be hooked up to the capacitor, the trimmer capacitor here. And there's yeah, okay, so I think what I'm going to do is I'm going to stop now, and tomorrow I'll explore this coil more fully. Then I think we'll have a reasonable grip on all three of these. And maybe at some point I'll figure out what is going on in this radio. Maybe. So maybe the name of the game is more that oscillation that it breaks into. Yeah, but you can't solve those things until you really know the circuit layout. Otherwise, wow, how are you ever going to solve it? Because a oscillation like that, very hard to track down. That's been my experience. Very, very hard to track down. Okay, yeah, that's it. How many times have I been saying goodbye? So, okay, we'll see you on the next video. Thanks a lot for watching again, and thanks for the super thanks. See ya.